Hello everyone. We are back with another video where we solve another classic Leetcode problem, which is longest substring without repeating characters. So for those of you who don't know what a substring is, a substring simply means a part of a string. The definition is given here. Whenever you go to solve it, you can surely go through it. It basically means any part of this particular string, which could be any number of characters, whether it is one or more, or whether it is the entire string. Alright. So that is the substring. We have to find a substring where none of the characters repeat. For example, in this particular string, we have a substring A, B, and C. This is one of the valid substrings that we're looking for because it does not have any repeating characters. On the other hand, if we take A, B, C, A as our substring, A repeats once, which is why we don't consider it a valid substring for our use case. Similarly, in the next example, we have a substring which contains n number of bees. We have 5 bees over here, it could contain n number of bees, one or more. What we are looking for is a substring where this character B is simply not repeated. Alright, so the answer would be 1 because we have to return the length of such a substring, which is the longest for a particular string and it does not have any repeating characters. So how do we actually go about calculating such a length? So we'll take the example that was given to us and we'll work with it. To solve this, we will use what we call a sliding window approach. What does sliding window mean? Basically, we'll take 2 points in this string at a time, let's say point A and point B. We'll take the substring out in here. We will see whether this substring is valid for our use case or not, and we'll keep moving this window, which is what is meant by sliding. We'll keep sliding this window, we'll keep changing the substring to see whichever fits our use case, and whichever is the longest, we will return its length. Okay, so how do we actually go about it? So what we're going to do is we're going to follow a two-pointer approach. We'll take 2 points at a time, as I just mentioned, for our sliding window. We will start off both points in the same place. We will check whether this substring, which is encapsulated by the 2 points, which is just A in our case, is this a valid substring for our use case? Is this a substring that only has unique characters in it? The answer is yes. So we will keep updating the answer as and when we progress. So answer in this case will be 1 right now. Then what we will do is we will move the right pointer. So we have 2 pointers, let's say left, and we have right. So we'll take the right pointer. We will move it forward. Okay. Then we check the next substring, which is encapsulated by these 2 points. Now our window is representing the substring AB. So what is the length of the maximum, what is the maximum length of such a substring now? Well, it is either 1 or whatever is the length of the current substring that has unique characters only. That is A and B make 2. So our answer will be updated to 2. Similarly, we keep moving forward. We go to C. Now, we still have a valid substring. Its length is 3. So we update it. Now, this is where we reach a tricky point. We have reached a case where we've encountered a character that is now repeating. So what do we do in such a case? In such a case, we have to update the left pointer. We say that, okay, we have the character A over here and as our right pointer. What we have to do is simply move the left pointer to such a position where we only have unique characters left in the substring, right? Right now, there is this A that is repeating. So we will move the left pointer to a point where only unique characters are left, which is now this case. All right. So we basically keep on moving this left pointer till we reach the desired result. We keep calculating the length while we do it. This is 3 again. We don't need to update it again because it's 3, which is what we had previously as our answer. Then we move once more. We encounter B. Now we see that our substring is not valid anymore. So we keep on moving the left pointer. Sorry. We keep on moving the left pointer. We check the substring. We see if its length is greater than what we had as our previous answer. The answer is no. So we move on with for the next substring. C repeats. So we have to continuously move till C is eliminated as part of our combination. Answer stays 3. We move forward once again to B. Now, this is another interesting point in our iterative process. We see that in this substring, B does repeat. In our previous examples, what was happening was that left pointer was pointing towards a duplicate character. Now, that is not the case, but our algorithm stays the same. I said that we keep moving the left pointer till all duplicates are removed from the substring. So right now, substring is A, B, C, B. All right. We move forward. Does the substring still have duplicate characters? The answer is yes, because B is still repeating. We move again. Does the string have duplicate characters? No. Is its length greater than what we had as our previous answer? Again, no. So we keep the answer as it is. We move the right pointer forward. Our window still has repetitive characters. So we keep moving the left pointer forward till we reach a string again, which does not have duplicate characters left. This does not satisfy our case. We move here. This does satisfy our case, but its length is only 1, which is less than 3. So our answer will be 3 in this case. Confirming it with the example, our answer is 3. Let's try the next example because it is a unique case that we have and it will help you understand the situation better. So we have our pointers. We see that the length of this substring is 1. I'll just remove all this for clarity. We update the value. We move forward. We see that there is a repeat. So we try to move the left pointer till we find a substring which has only unique characters. And we keep repeating this process till we find our answer. And in this example, I'm sure you can clearly visualize that we will just be repeating this entire process. So the answer will remain 1 till the very end. And that will be our answer, which is what is given to us over here. All right. Now you may be asking, why do we need to do exactly this? Why do we move the left pointer forward when we are trying to update our window? The reason for that is, let's say in this case, we have the left pointer over here and right pointer over here. This is the first position where we decided to move the left pointer to reduce the size of our window. All right. Why did we do it? Because we realized that in this particular position, every substring that starts with A has already reached this limit. What do I mean by that? I simply mean that any substring that can be formed that starts with this left position, the maximum length of a valid substring in such a case will always be 3, because after that we have encountered this one duplicate A, right? So we don't really need to test all the other combinations that come after it. We realize, okay, this is a duplicate value here, which we encountered in index number 3, which is where our right pointer is. And so what we did was that we stopped processing exactly over here. We said that, okay, fine, this A is not relevant anymore. So we move our left pointer because everything that could be tested with this particular A character has been tested. So we move forward, test the rest of them. And that is why we moved our window. All right. And that's basically how you solve this question. Now, what you can do to keep track of duplicate characters is you could potentially use a set. You could potentially use an object or a hash map. or a dictionary, something like that, depending on whatever language you're using, whatever you prefer to use. And theoretically speaking, the space complexity for using such a data structure would be big O of n. That is because at any given point, we could potentially be storing all the characters in the string. So if we have n number of characters in the string, O of n, big O of n will be our space complexity. Time complexity will also be big O of n in such a case, because we are going through this entire string, all the characters in the string exactly once. In the next video, we will be actually implementing this solution. So stay tuned and follow for more.